Hey guys, welcome to our help session for Lab 2. You do start off muted, so you're going to have to unmute your microphone if you want to say anything specific. I'm calling up our whiteboard as we speak. We're going to turn on screen sharing. So far, I'm not hearing any comments from anyone, just so you know. If you want to unmute, usually if you mouse down to the bottom of the screen, a little menu will pop up with a little slash through your microphone. Alternately, you can push the space bar if you just want to say something. All right, can you guys see my screen sharing at the moment?
Yeah, we can.
We have a little paint board in case we want to do some diagrams or calculations. Okay. Okay, I'm still not able to hear any comments from the participants. I will
Can you hear
start the
me?
chat. And as I'm writing in the chat, remember, if you want to make a question here that's going to be recorded for your participation points, please make sure that you write it in the chat because that's the record that I have after the meeting is over. Are you guys all able to see the chat?
Yeah, are you not able to hear me? Hello.
Okay, the chat likewise. I just put a comment in it, so hopefully it popped up for you. Okay, great. I am getting questions in the chat. Okay, so same as with our discussion forum, if you have a question, it's best if you think about it and kind of formulate it in your own words and include in the question kind of where you are and what you're thinking of. So we can kind of start from where you are instead of just answering the questions. Because the goal of the class is not just that I have 30 copies of all of the answers to the questions, because I already know what the answers to the questions are. But we can discuss this and hopefully we can address, I'm just going to have to guess where you're coming from and what you're thinking of so far. But the question was, what effect does air resistance have on the horizontal distance traveled by the ball? Oh, and also as a note for participation points, if you're just copying and pasting from the lab, then that wasn't written by you and that's not a thoughtful question, so it doesn't count for participation. But we can still help out with whatever questions you have. How would your results differ in a realistic setting with more air resistance? And if air resistance is turned on, does mass affect the range of the cannonball? So did you do it? What happens when you're in the simulation and you do those things?
Oh, can you hear me?
I'm still not able to hear anything from anyone.
Can you hear me now?
I can hear you. Can you hear me?
Let me change a setting there. Try again. Okay.
Can you hear us?
Okay, now I can. Sorry.
Okay. I was just able to hear the other student, and I don't know if she was able to hear us. I did just hear her.
Okay, so I can hear you now. I can hear two voices in the chat. Sorry about the technical difficulties there. Zoom always has a little bit of, it resets my settings every time I open it, so I have to change a whole bunch of stuff to make it work. All right,
Yeah.
great. So I can hear you now. So please repeat the comments. So what happened when you turned air resistance on in the simulation?
It caused the horizontal distance to be less.
Mm-hmm. And that's because when the ball's flying through the air, it's running into air, right? So
Yeah.
it'll change the total distance. So what happens if you do a heavy one versus a light one in that situation?
it'll change the range. Mass affects it as well. Where if when before without air resistance, mass was not affected, or mass didn't matter, right?
Okay, so this is the situation where mass starts to matter.
Yeah.
So for this class, we usually give you equations, like the air resistance equations, we haven't given them to you. They're a little bit more complex than what you would normally do. So the equations that you have, like if you were to, like it's within your mathematical capability to actually do this simulation yourself. You could say, hey, I shoot a ball, how far does it land? And you could do that with your kinematic equations. And the kinematic equations do not include air resistance. So as far as your kinematic equations are concerned, if you have a formula for your range, there's no mass in there. It doesn't depend on mass. But those equations don't include air resistance. So in the real world, if there's air resistance, that's an extra little term in your equation that basically what happens mathematically if you're deriving it is there's mass on both sides and they cancel out of your formulas. That's why mass doesn't affect it. Is however much mass there is, the force of gravity also increases proportional to your mass. And that force of gravity is what makes your ball fall, right? So if you have more mass, you have more force of gravity. If you have less mass, you have less force of gravity. And that's why it ends up canceling out and your ball will fall at the same rate. Does that make sense?
Yeah, that makes sense.
So mathematically, if air resistance isn't considered, mass doesn't make a difference. And also in the real world, there's always a little bit of air resistance, right? But depending on what object you have that you're throwing, normally that air resistance isn't enough to make a visible difference. Like it affects it a tiny bit, but not enough to really matter. And that's what we call negligible. It means we can ignore it, even though it doesn't exist in real life. In your simulation, if you crank up the air resistance, that changes the math a little bit, and you will notice that the more you crank it up, the more it does actually start to make mass make a difference. So does that make sense?
Yeah, it does.
All right, so if there is air resistance, it will make a difference. So you need to mention that. And this question number 6 that we read off, it has 3 different parts. So when air resistance is on, write about what happens when air resistance is on. And then how would your results differ in a realistic setting with more air resistance? Well, in a real setting, air resistance kind of depends on the ball. If you have a small, heavy ball, like usually we have like little steelies or something that we drop, air resistance is small compared to gravity, and so it doesn't make very much difference. If you started throwing like ping pong balls or something, that's something where the mass of the ball is small, so gravity is small, air resistance is a lot bigger, and it starts making a bigger difference. So your results that you did in this lab, though, were with air resistance off, right? So when it asks, how would your results differ in a realistic setting with more air resistance, you did check what happened when you turn air resistance on. So look at your graphs and your results that you got from the lab and say, what would happen if we did this whole experiment with the air resistance turned on? And then, the comments have already been made that once you do turn air resistance on, depending on how high you crank it up, mass does start to make a difference where normally it wouldn't in your simulation. So does all that make sense? Are there any like more detailed questions, anything confusing about that idea?
No, that makes sense.
Okay, great. Hopefully that's helpful then. Are there any other questions here now? I can also go back and we can check. There was a question in the forum that I accidentally kind of put a confusing answer too because it mentioned homework, and so these are usually called labs. The symmetric case, it calls your graph symmetric and non-symmetric. That's just a descriptive term. If once you make the graphs, if you do it properly, you'll notice that one of them is symmetric and the other one's not symmetric. So it's just calling it, it's an adjective for your two graphs to tell them apart, basically. And yeah, the one thing that you changed between those two graphs were that it came up off the ground. So, you know, a projectile motion in general, if you shoot something, and if you start at ground level, it is going to come up and it comes down and it hits the ground at ground level again. If you do it from a height, it's going to have some tail of something else where something else is happening that goes beyond the height that it was shot at. So it kind of has to be asymmetric. Okay, let me see. I will look at the. We had a question on drawing the chart, and a student answered it. Has that answer been enough to help out for the question that we had? It was kind of a general "how do you do it" question.
Yeah, I think so. And I just did it by hand. I printed it out, and that is fine, right?
Yes.
Okay.
So your lab, I encourage you to take this step and do it on Excel, just because it's actually a lot faster and a lot
Okay.
easier. I get a lot more kind of scary graphs that aren't looking like what they're supposed to be looking like when people do it by hand. And most people are not familiar with Excel, but the process of doing it in Excel is actually really quick once you learn it. So I do encourage people to take that step, but it is not required.
Okay.
Okay, let me see what else is. All right, yeah, there was a few comments back and forth on that descriptive term about the symmetric graph versus the asymmetric graph, but I do not see any further questions. I will just look at the lab again real quick and maybe give you guys a couple comments on things that usually hang people up if you would like. Okay, so make sure when you do the graphs, it says to graph, oh, I might have already fixed this one. You're graphing range versus launch angle. And what that means, some people sometimes get a little bit confused like by that. Can you guys see my like little whiteboard that I'm doing? Ooh.
Yeah, we can.
Okay, so this is obviously a very rough sketch. But you have the graph paper that you've been given, and you do not have to use the graph paper at all. If you have a computerized graph, just put that to PDF or take a screenshot or whatever you need to do and just submit it as an additional file in your submission. But your graph paper looks like this, right? They put the axis on it and label it. So when it says to graph something versus something else, the thing that you're graphing versus is on the x-axis. And the first thing that you're graphing is a graph of something that's this y-axis. So if it says to graph your range versus your angle, that means range is up here on this axis, and that's going to be in a certain unit. Usually you need to put your units there. And angle is down here. And you learn about functions and whatever in your math class, but your graph should be approximately this shape. I sometimes get graphs that are coming through like sideways that look like this or something, and that's not what we're looking for, because on the y-axis is range in meters and that varies over time. So each point here is going to be a data point, right, that you actually read off of your graph and put here. All right, so just so people have a general idea of what their graph looks like. Also, your data tables include time of flight. If the instructions don't ask you to put that on your graph, please don't put it on your graph. Sometimes people end up graphing completely the wrong thing. So make sure that what you're asked to graph is actually what you graph. Okay, so you're asked to make two graphs. You should be able to read the angle of maximum range off your graph. Just give me the angle. And just in general, another thing that I see a lot is some of these questions are compound questions. They actually have like 3 different questions inside of them. And often people give me a really great answer to like one of those and then forget the other 2. So make sure once you answer the question, go back and reread and make sure you got all the parts of everything that you were asked. That's a good hint. So you had an original prediction. Most of these are actually just descriptive, what happens to your data if you change the initial height kind of things. Especially on number 4, considering your time of flight, what effect does launch angle have on time of flight? Does this relationship depend upon the initial height of the projectile? So that is actually kind of a question you could read more than one different way. And so it's asking basically what happens to time of flight as you change your launch angle? Does that same thing happen if you change your height? So, and you can look at it 2 different ways. If you compare your case 1 and your case 2, where you change the height in between, they're not going to have exactly the same time of flight, right? So you could talk about that if you wanted to, but what the question actually says is, does the relationship with launch angle, does that look the same? And basically that, if you graphed that, which I don't think you're asked to, but if you did, it would kind of have the same shape, right? If you change your launch angle by a little bit, what happens to time of flight would be the same no matter what height you started at, but the higher you start, a little bit longer it's in the air a little bit longer, right? Because it has to fall all the way to the ground before it stops being in the air. So if you start at a higher point, it's going to have that much further to travel. So it's always going to be in the air a little bit longer in the case where you were higher off the ground. But the relationship between angle and time of flight, you should notice that that's basically the same. So you can talk about that as you answer the questions. And we already kind of talked about depending on mass. So you should be able to see in your data which this lab does not walk you through changing your mass or not, I don't think. And so if it doesn't, you might have to go back and check a couple things that kind of are extra, that aren't exactly what the directions told you to do. If it didn't tell you to try different masses, but the questions ask you what happens if you change your mass, you need to go back and actually check that. And we did talk about number 6 already. All right, so that's it so far. If anybody has any further questions, feel free to speak now. Otherwise, I think we've addressed all of the issues.
No, that works. Thank you so much.
All right, thank you so much. I will process the video and get it posted. And good luck with the lab.
Thank you.
Thank you.